This video on coordinate geometry of the line is our second video looking at slope. In our last video, we saw that slope could be worked out by using rise over run. But there's also a formula in the log tables that we can use to find slope. So get out your log tables and open them up to page 18. And you'll see that actually the very first formula there on the page is the formula for the slope of a line. And this formula is m equals y2 minus y1 over x2 minus x1. And you might notice even on first glance here a bit of a similarity between the rise over run formula and this new formula from the log tables. They kind of have the same format. They're both written as fractions. And you might notice that on the top of this particular formula's fraction, the y2 minus y1, they're values that are relating to the vertical direction because that's the vertical axis. That could be to do with rise. And on the bottom we've got x's, x2 and x1, and they're to do with the horizontal axis, x. And again, run is a horizontal measurement. So these two formulae might look a little bit different, but actually they're coming from the same place. And we use this log tables formula when we have coordinates on the line. So let's have a look at an example. So in this example, I've got a coordinate grid. I've marked in my x and y axes, and I've put the scales along them. And I've marked in 2 points A and B. And now the question asks me to find the slope of the line AB. You'll notice here that I'm not calling it a line segment because I don't have to stop at A and B. The line continues on in both directions indefinitely. And because it's a line, its slope isn't going to change no matter how far along the line I go. Okay, so I can see the 2 points A and B in my diagram. I'm going to start by writing those down. Make a note of these points yourself. So A is the point -1, -1, and B is the point 3, 2. And I want to find the slope, so I'll make a note of my formula, and I'll label my points just like I did in all my previous formulae. And now I'll substitute into my formula to work out my slope. So on the top of my fraction, I'm going to have y2 minus y1. Notice y2 is 2. I've got my minus in the formula, and here my y1 is -1. This negative obviously makes a positive, and you can write it as a positive if you like. And then on the bottom, we're going to have our x2, which is 3. Again, there's a minus in the formula. And my x1 is -1. So again, I've got that minus set up on the bottom, which I can write as plus if I like. And this won't happen every single time. It'll only happen if the value that you're subbing in at the end of each part of your fraction is negative. But do pay attention to signs because that's where the most mistakes get made in this. And then I'll go to my calculator and stick this in, or maybe you can do it mentally, and your slope in this case is 3 over 4. So we've found the slope of the line. Again, notice that this line is sloping up, it's got a positive slope, and the slope that I get in my answer here is a positive number. I don't need to draw in my rise over run, but just as a matter of interest in this particular example, I'm just going to do that so we can see how it links to the formula. So I've drawn in my triangle and I've marked my rise and run. And of course, from our previous video, slope was rise over run. And let's have a note here that rise is 3 boxes in this case, and run is 4 boxes across. And that relates to the 3 over 4 that we got from the formula as well. I won't make a habit of drawing in this triangle and noting rise over run, but like I said, it's just nice to see the link. So here's an example or a question now for you to do yourself. So pause the video here, calculate the slope, and then play the video and check if you're correct. And just note, in this case, you don't need to draw in the triangle to find rise over run. You can just use the formula y2 minus y1 over x2 minus x1. Okay, so the first thing that I need to do is make a note of my 2 points. C is the point -2, 3. And D is the point 3, 0. I make a note of my formula and I label my points. And now I'm ready to fill in my formula. So my slope in this case will be, okay, y2 minus y1. So that's 0 minus 3. I don't have a double minus this time. I just have the minus from the formula. And then on the bottom, I'll have x2 minus x1. So 3 minus -2. And of course, again, that double negative makes a positive. So I can calculate my slope as -3 over 5, and I'm not surprised to see it come out as a negative value because that line is sloping down, the line is decreasing. Okay, let's go on to look at a second example. So here's our second example. We've got our coordinate plane and we've got two points E and F marked in. We want to find the slope of the line that joins those. Notice that this time I don't have a grid, so that makes it much more difficult if I got an ocean to do rise over run. So I really want to use the formula this time. So I'll start by noting the points, and you can do that yourself. So pause the video here and do that much. So I'll start by noting my points, E minus 2, 1 and F3 minus 3. Now I'll make a note of my formula. And again, this can be found on page 18 of the log tables. I'll label my points and then I'll substitute my values in. So in this case, I'll get y2 minus y1, which is minus 3 minus 1, over x2 minus x1. And watch out for that double negative this time. So I've got 3 and then minus minus 2. Once you get the hang of it, you can just put the plus directly in if you like. And then I'll work my answer out. And my slope is minus 4 over 5. And again, note the line is sloping down. It's a decreasing line and it's got a negative slope. So now a question for you. So here's your question with a diagram and 2 points G and H, and you want to find the slope of the line GH. Pause the video here, do the question yourself, and then play and check if you're right. So G and H are the points minus 3 minus 2 and 3 minus 1. I'm going to make a note of my formula. I'm going to label my points, and then I'm going to sub in. And on top I'm going to have minus 1 minus minus 2. Again, that double negative makes a plus. And in the denominator, I'm going to have 3 minus minus 3. And again, that makes a plus. My solution comes out as 1 over 6. And again, it's a positive number. And the line is sloping up. The line is increasing. It has a positive slope. Let's look at example 3. In example 3, we're going to be given 2 points. I'm going to make them be J, which is 2, 5, and K, which is 4, 7. And we want to find the slope of the line that joins them. Notice that this time there's no diagram involved, and that is quite a common setup actually in coordinate geometry of the line questions. I might just be given the coordinates themselves and asked to go ahead and use a formula on them. And that's no problem. I'll just do exactly what I was doing in the previous questions. It's just that I haven't got a diagram to relate it to. So it's slope I want to find, so I'll make a note of the formula. And then I'll label my points as normal, and then I'll substitute in. And in this case, I'll get, well, y2 minus y1 is 7 minus 5, and x2 minus x1 is 4 minus 2, which is 2 over 2, or just 1. Even though I haven't got a diagram in this question, I can kind of get a vague picture in my mind of what the line JK might look like. I know that it's got a positive slope, so I know that it would be sloping up. The line would be increasing. So now here's question 3 for you. So this time I have a line with the points L and M on it. L is the point 4, 0 and M is the point 0, 3, and I want to find the slope of that line LM. Pause the video here, do the question yourself, and then check and see if you're right. Okay, so first thing is that I want to find slope, so slope formula has to go on the page. Then I need to label my points, and then I'll sub in. On the top I'll get 3 minus 0, on the bottom I'll get 0 minus 4, and when I stick this into the calculator, I get a slope of minus 3 over 4. So again, even though I haven't got a diagram, I can kind of visualize the line to a certain extent. I know that it'll have to be a decreasing line because it's got a negative slope.